Welcome to another GC Basic tutorial. This is for the 16F175 chip family. What we're doing this time, part 5, we're going to look at a switch to set the state of the LEDs. And this is representative of an use of an input. So far in the videos, we've used outputs. So let's get started on this digital input. Like and subscribe, please. I'm in it for the votes and for the subscriptions. Please do that. So, number 5, as I just briefly said, we've used outputs. We've also used the digital inputs. That's the ADC. We're now going to use a digital. Did I say digital ADC? I mean analog DC ADC. A digital input to set the state of the LEDs. So it's a switch. I'll briefly just look at this. The PIC16175xx chip family is the latest PIC16 available, and comes in various products. Okay, so I'm assuming that you've installed the GC Basic software. It all works. You've got it connected up. You've tested that you can connect your chip. You have 4 LEDs. A potentiometer still connected from the last tutorial, and now you've connected up a switch. So I'm going to show you what I've done. So here we are with developing this diagram. I used this in the last tutorial. I've actually added in a switch, and you can see that on pin 5, RA3 is a switch. And if we look at the diagram over here, put my pointer on, it's connected to RA3, which is here. I've got the switch connected really through to ground loop here, but I've actually got it pulled up it's pulled up, even though it's drawn in a down manner, using a 10k resistor, because this 10k resistor is pulled up to 5 volts. I do have a current limiting resistor here of 1k on that switch. This is good practice. So if we just look at what we've got there, I'll just re-raise all those. This limits the current, and the current is going to come from the high volt round here, and that's pulling it to 5 volts into the switch. That's what the protection is. So I've got it pulled up with a 10k and current limited on 1k, and that's really good. Okay. This is the diagram I'm using to sort of lay out where we are. I just turn my pointer on. So I've connected my switch to port A3. That's where that switch is, and we'll have a look at that in a moment. So let me go back a slide, and I'm just going to zoom out to the desk cam. There's desk cam. That's where we left it previously. My pointer's here. So I have got 4 LEDs here. What we're interested in today, we're going to toggle those on and off. And I'm going to connect, let me just grab a cable. I'm going to create a flying lead like this to port A3, which is over here on the right hand side. Hopefully you can just see me connecting that. And I've got a set of switches here. Look. Some of these are pulled high, some are pulled low, but I know that my lower switch is pulled high. So I could sort of push that at any time, and I'm actually toggling port A3. Now, this is the old tutorial, so obviously nothing happens. And we'll have a look at that change. So what we're going to do is initialize the microcontroller, check the switch. If it's been pushed, toggle the LED. If it's not pushed, just go back and check it again. We have a function, so I'm going to introduce a function as well, and it's going to return the state of the LED. So this introduces a function, and we can call that function to check the state of something or do something. Then it will return a value, in this particular case, true or false. So in our flow diagram, we initialize, we set the LEDs off, just turn everything off, wait till the button is being, the key press is true. If it's true, if it is true, that means it's yes. It toggles the LEDs and it just loops back. And obviously the other action is if it's not true, and then it will just loop back and keep checking. Now, so what we're going to do is review the GCStudio options. We're going to look at some sample code and just review the result on the hardware. So let's Keep that on the screen. I'm just press Windows, pop it up. GCS will start up GCStudio, and I'm into GCStudio. I'll zoom in on that for you. This is the, let me shuffle that, there we go. So this is the screen we've seen before. Let's have a look at what else we can do whilst we're in here. Well, bottom left, report a bug. There we have a bug reporting tool. Click on that, it will take you to the page. Please leave your email address so we know who we're talking to. If you want to, please donate to the project. Take the next one on the right, this left one here, sorry. Now, all the demonstrations that we're working through at the moment, you can install a whole pack of demonstrations. If you take this link here, it will take you out to SourceForge and download all the demonstration packs, including the tutorials we're looking at now. And finally for today, we're going to look at the About. The About tells you a bit of information about GCStudio. Tells you the version numbers in these modules here up the top right hand corner. If necessary, you can create a dump file from that and help us debug issues. Its acknowledgement, license and readmes and the full changelog, roadmap and report a bug are also there on the left. You can see that this is GCStudio for Windows and it will work as well on Linux, etc. But this particular release this year is for, for our friend Bill Roth. Bill unfortunately died in 2025, and we truly miss Bill's thoughtfulness, insights and guidance with GC Basic. So we're in here, we've seen this before. I'm going to take up the option that has opened the recent, and later on we'll come back to this and we'll look at the spanner at the top left hand side, top right hand side, sorry. Open that up, it takes us into the IDE, which we've seen before. I'll go full screen so we can see it. There we go, full screen, we've got the logo. Okay, Control B or open the Explorer if it's not already open, and take 070 debounce the switch, because we're actually going to debounce the switch as well. Okay, so click on it, has opened it up. Control B, just to get rid of that. Now, everything in green we've seen before is commentary, and I'm talking you through that, so I don't really need to talk. We don't need to read it. We've got our standard header, hash chip, and the chip specification, and we're going to run it at the maximum frequency so we don't put any more parameters on there. Option explicit, we've seen a few times, means we have to define any variables. And here is the switch in our little diagram. We've seen all the constants being defined, so I'm adding more constants as we're progressing through, and the ones I'm defining today is define switch, switch in. That's a new constant, that's on port A3, because that's where our switch is. And I'm setting that as an input, dir, switch in as an input. And then you can define down. And now if you've got I have it set as 1, that's because I have a pull up. Depending how you do your wiring, if you can take this function, you can play with down being 0 or 1. So it's really, it sets the state. That is the norm. And you can invert that depending if you pull down or pull up. So I've got it set to 1. You can choose that either way. So let's have a look at our complete program. Complete program. It's only a few lines long. Do forever is the same as a do loop. Do forever is an internal, just like you just do it. Do that rotate. Do forever. Wait 10 milliseconds. That was missing from my flow diagram. And it says, if function key pressed, look at a function, I sort of gave it a name so that you knew what it was. And you can put some braces on it because you can pass it parameters. There are no parameters, but I'm doing that for clarity. You could actually not have the braces, but it's good practice. And it returns true or false, and we'll look at the function shortly. Then, if it does that, it will toggle the LEDs. And we've seen this in tutorial 1 or 2, where we've said whatever the existing state is, RC0 equals not RC0. RC1, not RC1, RC2, not RC3, etc. So they're going to toggle. So what we should do here, let's look at the desktop, there is webcam. Let's program that. I'm going to take the make X and flash. I could press function key F5. They'll all do the same. So I'm just going to click on that. It's now compiled it. Now, over here, the LEDs have stopped flashing. Why? Because it's waiting for me to push a button. I'm going to push a button. Now, this has got debounce on it and a whole load of other checks in it, but you can essentially say, if RA3 equals 1, then toggle the LEDs. But you're not doing the debounce. So what's in this function is sort of important. So I could say, let me just take my variable here. I could put that in there and it would work, but that's not what we're looking at here. I want to look at this function. So what this function does, and it's fully documented in the presentation, but I'll go through it here. I'm introducing and defining a function, and a function starts with a name and the type, and this is a bit. We've seen a byte and we've seen a word. We're now introducing a bit. So a function key is a bit. It's either 0 or 1. And a function ends with end function. And that's quite good. So how do we return this value of function key pressed? Well, we set that to 0, 1 as we exit out. So let's go through. I define a couple of other bits that I need. I need to know what the current state is and what the last switch state is. I wait for 1 millisecond. And so every time it comes in, it waits 1 millisecond and then carries on. It says if the switch is down, so that means it was set to a 1, and then the current, it just sets the switch state. It sets it high or low. It says it's true or false. So it just sets the current switch value to either 1 or 0, depending how you set that toggle at the top. And then it says, well, if it's not equal to the last switch state, then quite clearly something's changed. It says, I'll set the current switch state to the last switch state because we already know that the state has changed. And it says, right, I'll set the exit value to the current switch value, which is, look, current switch function key pressed equals whatever that new state is. So that's how it toggles. If you set the down value to 0 or 1, you don't have to reprogram it in the function. It just will always toggle. It will always toggle. And then it says here, if nothing's changed, then return the function key pressed as false. So it's simple. It just does it very quickly, in and out, very fast. And so when it exits out, it sets the function key pressed to either true or false, and that's how that function works. It just says if it's true, then toggle. I push it. I push it. Look at that. So simple. This is one of the simpler programs that you can write. You can reuse that function key pressed, in all of your programs. If you want to change the behavior, have a look at it as a basis. Back to PowerPoint. So I wanted to look at that as an input. So what we're going to do now is just exit out and leave you to it. So I've defined in the presentation set a fully documented function for you. I've sort of laid out the variable definition, the initialization, the debounce loop, and a return stable. So how it returns a stable result. Let me know if you want to change it. Your comments would be great, but I did document it. So next, using the reset switch, we've seen one switch, and that's just a digital input switch. We're going to use the reset switch to do some other actions and how we can reset the chip and how we can use the reset as an input, and we'll see how that works. Enjoy.